Core Mathematics C12 Sample Paper Part 2 Questions 6, 7, 8, 9. Question 6. Remainder Theorem. Fx is a function and we know that when fx is divided by x minus 1, the remainder is 7. Remember, the remainder theorem is fa equals to remainder when fx is divided by x minus a. So question number A, we can use the concept. So f1 equals to 7. That is the remainder theorem. So let's put the value of f1 in the original expression. It would be x to the power 4. So 1 to the power 4 plus 1 to the power 3 plus 2 1 squared plus a times 1 plus b equals to 7. So this turns out to be a to the power 4 is 1, a cubed is 1 plus 2 plus a plus b equals to 7. So 1 plus 1 plus 2 is 4. So 4 we can write a plus b equals to 7 minus 4. Therefore a plus b equals to 3. That's what we have to show in question number A. In question number B, we have another information. When it is divided by x plus 2, the remainder is minus 8. So similarly, we can write this time f minus 2 equals to minus 8. So when we have x divided by x plus 2, the remainder is minus 8. That means f minus a equals to remainder if fx is divided by x plus a. That is the idea. So let's put the value again. So x to the power 4 means minus 2 to the power 4 plus minus 2 cubed plus 2 minus 2 squared plus a minus 2 plus b equals to minus 8. So we will have 16 plus minus 2 cubed. Since the power is odd, it is going to be minus 8 plus minus 2 squared is 4, 4 2s are 8 minus twice a plus b equals to minus 8. So we will get 16 minus 8 is 8 plus 8 is 16. So that means this two cancels, we get 16. So minus twice a plus b equals to minus 8 minus 16, which is minus 24. Let's multiply both sides by minus. It becomes twice a minus b equals to 24. Now we have two equations. So what we have to do is solve the simultaneous equation and find the values of a and b. So a plus b equals to 3 is equation 1. Twice a minus b equals to 24 is equation 2. This is still part of question B. So when we cancel plus b and minus b, and we can add this up as thrice a, this would be 24 plus 3 is 27. Therefore a equals to 9. And we can put the value over here. A plus b equals to 3. Therefore b equals to minus 6. So answer a equals to 9, b equals to minus 6. Question 7. Recursion series. The idea of recursion is that it is not direct. You cannot find the second term without the first term. You cannot find the third term without the second term, and on and on. It is interconnected. That is recursion. So the first thing that we have to do, we have to find a2, an expression for the second term. Well, you see this n plus 1, this represents the next term, and n represents the previous term. So that means if you plug in here n equals to 1, here would be 1 plus 1, 2, that is a2, equals to 3 a1, because n equals to 1, minus c. Now it is given that a1 equals to 2. So that means 6 minus c. That is question number A. Now in question number B, we have a summation, which is I equals to 1 to 3. That means the sum of the first three terms. So summation of I equals to 1 to 3, ai equals to 0. That means, so the first term is a1 plus a2 plus a3, and all of the terms together is 0. Now one thing is very, very important. This is not an arithmetic series. It's a recursion series. So we have to do this summation individually. So let's find A3 first. So A3 is 3 into the previous term, which is A2 minus C. So A2 we just found 6 minus C. So it is going to be 3 6 is 18 minus 3C minus C. This would be 18 minus 4C. So now we have A1, A2 and A3. So we can write hence A1 is 2 plus A2 is 6 minus C plus A3 is 18 minus 4C, and all of this is equals to 0. So let's solve this. 2 plus 6 minus C plus 18 minus 4C equals to 0. That means 2 plus 6 is 8. 8 plus 18 is 26. So we have 26 minus 5C equals to 0. Therefore, 26 equals to 5C. C equals to 26 by 5. It is important to remember one thing. If they do not mention how decimal places or significant figure, then it's a good idea to leave the answer in exact form. Question 8. Quadratics. Discriminant and solving inequalities. First of all, ax squared plus bx plus c equals to 0 is a quadratic equation. Now it has two roots, meaning unknown values of x, x1 and x2. We are not interested in finding out at this moment what these roots are. We are just interested in finding out what is the nature of the root, meaning whether it's a real root or unreal root. Unreal root can happen in one situation. First of all, the way to find the root is the quadratic formula, x equals to minus b plus minus b square, square root of b square minus 4ac divided by twice a. Now if b square minus 4ac, this entire thing, b square minus 4ac, if this is negative, we know that square root, negative inside a square root is not possible. That's why we will say that the roots are unreal. That means b square minus 4ac is less than 0. But if it is more than 0, that means if b square minus 4ac is positive, then we will have a value for square root, and that's what we are having here. Has two distinct real solutions. That means there are two different values of x, and that is only possible if square root of b square minus 4ac has some value. Then we can find minus b plus of that value divided by twice a, and minus b minus of that value divided by twice a. So for real and distinct or different roots, we have to remember that b square minus 4ac will be positive. That means greater than 0, and that is the idea behind this particular sum. One more thing. Here a is k plus 3 because it's in terms of k. So we have to write for real and distinct root, we have to write b squared minus 4ac is greater than 0. Remember, we are not interested in the actual root themselves. We want to, we know that they are just real and different. So b squared, b is the coefficient of x, which is 6. So 6 squared minus 4. A is the coefficient of x squared, which is k plus 3. Times c. C is, now this has to be in this format, equal to 0. So since it is not in that format, we have to make it in this format. So it should be k plus 3 x squared, ax squared, plus 6x bx plus k minus 5 equals to 0. It has to be in this format, otherwise we will not know what the value of c is. So c is k minus 5 equals to 0. So now let's simplify this. See what happens. 6 squared is 36 minus 4. Now let's multiply k plus 3 with k minus 5. K into k is k squared minus k into 5 is 5k plus 3 into k is 3k minus 3 5s are 15 equals to 0. 36 minus 4, we have k squared minus 2k minus 15 equals to 0. So we have 36 minus 4k squared Minus 4 into minus 2 is plus 8k. Minus 4 into minus 15 is plus 60 equals to 0. So this is going to be minus 4k squared. I'm writing equal to sign. This should be greater than. Let me remove this. So this should be greater than, greater than, greater than. Okay. So plus 8k, 60 minus 36 is plus, this is 60 plus 36 is plus 96, greater than 0. So let's divide both sides by 4. That becomes k squared plus 2k plus 24 greater than 0. Now let's multiply this by minus. It would be k squared minus 2k minus 24. Now remember, when you multiply something by minus, the inequality is reversed, so less than 0. And we have shown k squared minus 2k minus 24 is less than 0. Question number B. Now we have to solve this inequality and find the set of possible values of k. To solve a quadratic inequality is, first of all, we have to factorize it. So let's factorize this. K squared minus 24 is 6 4s are 24. So minus 6k plus 4k minus 24 less than 0. That means 4 minus 6 is minus 2. If we take k common, it would be k minus 6. If we take 4 common, it would again be k minus 6 less than 0. And this would be k minus 6, k plus 4 less than 0. Now what we can do over here is use a parabola for doing this. So think of this plus k squared, we have a parabola over here, and the values would be, if this were instead of less than 0, if it was equal to 0, it would be minus 4 and 6. These two would be the values. Now since it is less than this line, the region between the curve and the line is this region. So the answer would be between minus 4 and k. Now the question is, write down the set of possible values, and that is written as k colon second bracket, that is sets. Question number 9, logarithm. In order to do this sum, we need to know two main rules. First of all, if we have log a plus log b and the bases are same, we can write log a times b. Similarly, if we have log AB, we can just unpack it and write it as log A plus log B. Another rule that we have to know is, if we have log A base A, then it is the same as 1. So let's start. We have to show that log base 3 y is the same as 1 plus 2 log base 3x. Remember, this is not an equation that we have to solve. We have to show that the left hand side is equal to the right hand side. So let's start. Log base 3, instead of y, we have to write x, because here on the right hand side it's all about x. So y equals to 3x squared. So let's use this rule over here and unpack this. So we can write log base 3 plus log base 3 x squared. Now we know log base 3 is 1 plus. Now when we have a power in front of a log, we can bring the power in front. So this can be 2 log base 3x, and we have expressed it like right hand side equal to left hand side. Question number B. This time we have to solve it. There is no right hand or left hand. It's one equation. So it is 1 plus 2 log base 3x equals to log base 3 28x minus 9. This is the equation that we have to solve. The first thing we have to do is bring all the logarithms on one side and all the numbers on the other side. So let me write this as log base 3x squared. Remember, this 2 can be written here as a power minus, I'm bringing this logarithm to the left hand side, log base 3 28x minus 9, and on that side we have minus 1. Now in order to solve this, we need two more rules. The first rule is that if you have log a minus log b, you can write it as division log a by b. And finally, if you have a single log equation, log base ax equals to b, The solution to that equation is x equals to a to the power b. That is the main rule for solving equations with logarithm. So first of all, subtraction is division. We can write x squared divided by 28x minus 9 equals to minus 1. Now we have a single logarithm form. So let's use that rule to solve this. So this is going to be x squared by 28x minus 9 equals to 3 to the power minus 1. Remember to give here therefore, because this line and this line, this is the formula you're using. So now let's simplify this. So this is going to be x squared divided by 28x minus 9, and this is 1 by 3. 3 to the power minus 1 is 1 by 3. So we can write by cross multiplication 3x squared equals to 28x minus 9. So we can write 3x squared minus 28x plus 9 equals to 0. We know 3 9s are 27. So this is 3x squared minus 27x minus x. That way it is 27 1s are 27 plus 9 equals to 0. So this is going to be, if we take 3x common, it would be x minus 9. If we take minus 1 common, it would be x minus 9, and we have equals to 0. So we have x minus 9, 3x minus 1 equals to 0. Therefore, x equals to 9 or x equals to 1 by 3.